Hello everyone, welcome to the Simple Spark YouTube channel. In today's video, we are diving into a super important topic in electricity, Ohm's law. What it is, how it works, and why it matters. Ohm's law is named after George Simon Ohm, a German physicist. In 1827, he discovered a relationship between voltage, current, and resistance in electrical circuit. This relationship is written as V is equal to IR, where V is voltage, I is current, and R is resistance. The SI unit of V is volt, and SI unit of I is ampere, and the SI unit of resistance is ohms. Think of an electric circuit like water flowing through a pipe. Voltage is like water pressure, current is like flow of water, resistance is how narrow the pipe is. So, if you increase the pressure, that is voltage, more water, that is current, flows. But if the pipe is thinner, that is higher resistance, less water flows. Ohm's law tells us how voltage, current, and resistance are related in a circuit. It states that the current flowing through a conductor is directly proportional to the voltage across it, as long as the temperature and other physical conditions stay the same. In simple terms, if you increase the voltage, the current increases too, but only if resistance stays the same. Now, here is the key formula. V is equals to I times R. That is, voltage equals current multiplied by resistance. So here V stands for voltage, I is the current, R is the resistance. From this, we can also get resistance R equals voltage divided by current. And finally, if the voltage stays the same, the current is inversely proportional to the resistance. That means as resistance increases, current decreases. Now let's look at the explanation to verify Ohm's law. We start by setting up a circuit with a nichrome wire as the resistor, an ammeter to measure current, a voltmeter across the wire, and one or more cells to provide voltage. We vary the number of cells to change the voltage. Each time we do this, we record the voltage from the voltmeter and the current from the ammeter. Then we plot a graph of voltage on the y-axis and the current I on the x-axis. If the graph is a straight line, it confirms Ohm's law. This means that voltage is directly proportional to current. The slope of the line gives the value of resistance. So, for each reading, the ratio V divided by I remains constant, and that constant is the resistance. And that's how we prove Ohm's law with simple setup. Let's consider some of the values to find out the current. Values given are voltage is 6 volt, resistance is 3 ohm, and you have to find what is current. Given V is 6 volt and R is 3 ohm, we can find the current. We know the formula V is equal to IR. Substitute the values of V and R. So we will get 6 is equal to I into 3, and where I is equal to 6 divided by 3. So the current value is 2 ampere. Similarly, try for other problem. Given voltage is 12 volt, resistance is 4 ohm, and watt is I. We know the formula V is equal to IR. Substitute the values. We will get the current value as 3 ampere. Ohm's law helps engineers design safe and efficient electrical devices. A phone charger must give the right voltage so it doesn't overheat. Electric heaters use high resistance to produce heat. If you use the wrong voltage or resistance, things can overheat or stop working. That's why understanding Ohm's law is so important. Through a simple experiment with a nichrome wire, we showed that when we increase voltage, current increases, proving Ohm's law with a straight line V versus I graph. We also learned that resistance is equal to voltage divided by current. If resistance increases and voltage stays the same, current decreases. Understanding Ohm's law helps us design safe and efficient electric circuit from light bulbs to phone chargers. Now you know how voltage, current, and resistance are all connected. If you found this helpful, give it a thumbs up and don't forget to subscribe to Simple Spark for more easy to understand science lessons. Thanks for watching.